Hello boys and girls, it's day 14, Thursday the 9th of April 2020, day 14 of our lockdown. It's quite cold and miserable outside. Well, it's nice, it's overcast, hopefully we'll get some rain. Yesterday we didn't get any test results from our government. So I've done some sort of calculation, halved the difference between the previous day and today's results to give us yesterday's test. We'll see that in the spreadsheet. Infections 1485. That's up 5.49% day on day. Deaths, we've jumped to 18. Our mortality rate 0.98%. Total tests we've conducted to date, 63776. I've added a new column. Basically, we're taking the difference between the 2 days of the total tests to give us the tests per day. So our test per day, yesterday, 2839. Of course, we can't believe it because we didn't get yesterday's or the previous day's test results. Our infection rate is 2.89%. In the news, we're still getting reports from certain suburbs and rural areas where the guys refuse to lock down or stay at home, stay isolated. And unfortunately, it is what it is. And I think as the test rates, as the test results come out, and as the testing increases, we are going to be in for one hell of a shock. Like I said, we've tested roughly 2,839 people yesterday. Now, if you remember from previous podcasts, we said that they're capable of testing about 5,000 people a day. On average, if I look at the whole thing, we're testing about 3,100 people a day. So yeah, we are way behind the curve. Interestingly enough, the minister who was bussed in social media having lunch with her colleague or whatever has been suspended for 2 months, which is quite good. Another interesting thing, some AB InBev SAB trucks were bussed yesterday transporting alcohol. Now, according to the lockdown regulations, we're not allowed to be transporting alcohol, whatever. But what is interesting is they had all the permits in place to do this. They were transporting, apparently, they were moving their certain stock from one place to another. The news is a bit unclear. They were saying they were moving it from one warehouse to another, which doesn't make sense. In all likelihood, what I think has happened is, because of being on shutdown, obviously these things don't just stop overnight. What had happened is that whatever brewery they'd finished, that bunch of batches, they'd obviously bottled, canned, and done whatever they had to, and they were moving it to storage. But that's just my speculation. Of course, I saw this tweet last night, and I retweeted it jokingly to a friend of mine. I said, Dave, well, I guess they're not going to be delivering to me. And then I said, seriously, I wonder where the hell was this going? Where is it being delivered? And of course, now we get the news that they were actually moving it to a warehouse. Stupidly, they had all the permits in place, so I don't actually understand how the cops could have locked them up if they have the permits. Anyway, making a big show of nothing, presumably, and that's really what it is. So if they had all the permits and whatever, and AB InBev has jumped in and got lawyers for their drivers and whatever, and they've said they had the necessary permits to move their stock, I don't see how the police could stop them. Well, they can stop them, but I don't see how they can not let them continue or impound them, because I would presume that the drivers would carry that permit with them. The value, they say, was about 13 million rand. So it's not too much in the greater scheme of beer. Today, what I thought, we won't do an OBS, take the piss out of the news thing. I thought we'd do a repair, and we'll try and do a repair, because in all likelihood I probably won't have the parts to repair this. But we can see, what I would do is we'll do this repair in real time, because I often get asked, But how long does a repair take you, and is it economical, or is it economically viable, or whatever? Now, this is not my full-time job. I work as a CNI engineer. I build nipple plants, big plants. I do design work for that. I write code for that, control systems code. That's what I do for a living. I take on electronic repair to keep my eye in, to keep my hands in, and to see how technology changes, and that's why I do repairs. But people often ask me, how long does it take you to find a fault? And it depends. If I'm shooting a video and I have to work around a camera, it could be a while. But in general, if you cannot find the fault and repair it within 45 minutes, half an hour to 45 minutes, you're really not going to make this a viable living in South Africa. I can only speak for South Africa. You know, what we can see in South Africa, when I was growing up, you had electronic repair shops left, right and center. Today, you have cell phone repair shops left, right and center, and they don't repair electronics, because electronics has got to the point where it is cheap enough just to junk and throw away. If you take the service technician engineers rates into account and the cost of the spare parts. So I thought, let's do this repair in real time. It's a friend of mine, a colleague. It's his wife's treadmill's control board, and they've just had a new little one, and they asked me to have a look at this treadmill control board. It's one of those Trojan treadmills. Basically straightforward control board that controls the treadmill motor. In other words, the speed of the belt and whatever. Trojan, I don't know if it's a common make. It's very common in South Africa. You don't really find many other brands. So I don't know what it's like worldwide. We don't need schematics for it. The secret to this is to know your basic circuit building blocks. You don't really need circuits for most things. Ideally, if you get to something that you don't know what it is, a component, whatever, download the data sheet, and that will give you a good idea of how it fits into the circuit. So anyway, let me get the camera set up and let's jump onto the bench and let's take a look at this Trojan treadmill control board. Right, here we have our Trojan treadmill control board on the bench. Nothing really complex about it. We can see we've got our AC line, AC neutral inputs. We had a fuse there, that's gone. There's a little fuse in there. Bridge rectifier, bulk storage capacitors for filtering. Nothing really complex down here. In here looks like some sort of or must be FETs and whatever for our DC out, because that's a M plus, M minus, if you can see on the board. That'll be for current sensing. Optocouplers down here, processor down there. We've got some inputs, obviously, from the keypad and whatever. But if that fuse is gone, or in all likelihood that fuse is gone. So the first test we can do is we can switch our, I'm just going to zoom out a bit. What I'm going to do, I'm going to measure that fuse down there for you. So I'm just going to zoom out so you can see on the multimeter as well what I'm seeing. So let's try and get in here. If I measure across there and there, open circuit. Just make sure I'm getting it in there. Okay, so that fuse is gone. So we must have had quite a bit of a short on this board. Let's take a look at the output. So I'm going to measure across there and there. Let's try and keep my hands out the way. .4 ohm, 0.3 ohm. So the output is dead short. So that tells me we have a problem with their switching transistors, MOSFETs, whatever they're using. Let's zoom out a little bit more. What I can do is I can replace these two fuses, just short this out quickly, and we can measure the input impedance, but I don't suspect that there's going to be a problem there. As you can see, sorry about that, this board is mounted on this massive heatsink thing. So what I'm going to do is I'm just going to release these standoffs, take these screws out quickly. There's one missing. Interesting. Yeah, let's do that. Should we do this on camera? Why not? We'll try and do what we can on camera. We'll just take these off quickly. Yeah, it's Easter weekend, and it should be interesting to see how this unfolds in South Africa, whether the guys can actually stay put and stay home. I unfortunately have to pop out to the shops a bit later. I'm running a bit low on some essential provisions like bread, milk, and that sort of stuff. So I need to pop out. Okay, that one doesn't want to come out very easy. Let's get another screwdriver. Clearly the one I'm using is too big. Come on. No. Okay, but that's okay. I see why. If you see, I won't be able to turn it because there's actually a nut on the bridge rectifier. No worries, we'll take it off from this side and just use a nice long nose pliers. So what you can see is it's now loose, so we should be able to take it out much easier. Of course, and I've picked this up before, but it shouldn't be the case in this board, because you've got a nice massive heatsink on this board, so I can't see that the MOSFETs failed because of heat. Let's take that one out again now, if we can. Because normally these MOSFETs can deliver quite a whack of current. Of course, they'll be using pulse width modulation to actually control the treadmill motor. Okay, so we've taken that out. Now to release these, I'm just going to use a long nose. You just pinch it in. It's quite distracting working behind the camera because I keep looking at the camera instead of what I'm doing, and that really confuses me. Then again, I'm a man, a simple creature. last one down here. Have I released it? Yes, I have. They all released. So there's our board of our heatsink. Relatively dirty. That doesn't matter, we'll give it a clean afterwards. Right, so we need to know what the heck these are. That looks like a nice big fit down there, and it looks like they've got some sort of shielding on the, but why? No, it's just a, looks like a plastic holder. What is that down there? Okay, voltage regulator. To me, it looks like a, oh, that little one in there. 7815, so 15 volt voltage regulator. Okay. Right. Let's get this a little bit cleaned, and then I'm just going to brush it off outside, and then we'll come back to it. No point in keeping the camera running for that. Right, we've given it a nice bit of a brush off. It's a bit cleaner. I've of course got half the heatsink compound on my hands. The secret to putting that on is don't put too much, because the problem when you put too much on, it becomes an insulator. The heat cannot escape properly from the component to the heatsink, so you want to have a very, very thin layer on it. Anyway, we've got it off. Let's have a quick check what can be the problem. Let's see if I can balance it. Too big. No, too big. Okay, metal capacitor. No, it's not going to work either. Sure, but have I got anything to balance this against? Yeah, we go. This should work. Oh, too small. Oh, Craig, it's not your day. Anyway, so first things first, let's check these fits. From left to right, well, from bottom to the top. Normally, that'll be your gate, your source and your drain. Normally, either way, your drain, source and gate should not be common. So we'll set it to diode mode. Little multimeter. Hope I don't block you out. I'm just going to measure between the legs. Oh well. Short, short, short. Now there is a body diode in there, so if I reverse it, oh no, it's still stuffed. So that is gone. We'll do the same. Yeah. Short, 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 short. Well, there's your problem with this board. So what are those part numbers? Do we even have anything like that? I'm going to try and see under the camera or off the camera. No, I can't see nicely. Let's just move it this way. No, I really can't see. But that is real-time fault finding for you. I definitely don't think I have those two components, so I won't be able to repair it. If you're wondering how long it took, well, there you go. 2/3 of a cup of coffee. And that is with moving the camera to a different tripod. So what I'm going to do, I'll desolder those two components. We'll order some stock, and we'll hope one day when we get out of lockdown it'll get delivered. Then we can repair this board. Obviously we'll replace those fuses. But what I will do is I will pull these. I'm not going to do it on camera because it's difficult to work around the camera working with the soldering pump that I have. I have one of those manual ones, so that's a bit painful. But what I will do is pull those components. I'll pull that fuse and then order the new components, and when we get them we'll put them in together and we will run some further tests on the board. But that's really how simple it is to fault find. We know the inputs are blown the fuses. We could have checked the bridge rectifier, but I don't suspect. These are nice big bulky beefy bridge rectifiers. I don't suspect that, and there's no visible damage here on anything here. It looks relatively neat. Let me just zoom in a bit. Our nice little optocouplers down here, controller down there. Obviously let me lock the focus, otherwise I'm moving my hand in. So our controllers and various drivers. Looks like another voltage regulator, but nothing visibly looks burnt or hurt here. So we measure the output impedance, and if we're measuring a short here, well, it tells you you've got a problem here. So anyway, that's set up for the end shot, and that is our repair for today. Right, there you have it, boys and girls. Fault finding live, and you can see it doesn't have to be that difficult. With a little bit of deduction, knowing your basic circuit building blocks, it becomes rather easy. Of course my videos are normally much longer because I like to talk a lot of crap while I'm doing whatever, but yeah, the real life fault finding is normally very, very, very quick. Anyway, I hope you enjoyed today's video. Please, while you're in lockdown, stay safe, stay home, stay isolated, and until the next one, take care. Cheers.